So now we're going to look at matrix multiplication. And this will be a little unsatisfying in the sense that its definition is not going to be as maybe we would like it. So we're going to work through several examples that will build us up to where we want to be. The first one is going to be taking a row, so 2, 1, 3, 1, and we're going to multiply that times a column matrix, 2, 4, 1, 0. And the way that we define matrix multiplication is essentially a row times a column repeated over and over and over again. And when we set this up, we multiply corresponding elements and then we add them together to get our product. This is how it's defined for matrix multiplication. So we're going to multiply the first element here and the first element in the vertical matrix together, and we'll get 2 times 2, which is 4, but I'm going to write it out deliberately as 2 times 2. And then we're going to add to that the product of the next corresponding elements. So the second element here, 1 times 4. And then we'll add in the next product, 3 times 1. And then finally, 1 times 0, which is obviously 0. But again, I'm going to write this out deliberately so we have it all written out. And then we just add up all of that, and that turns into 11. So this now becomes a 1-by-1 matrix, and its only element is the number 11. So this is the fundamental part of multiplying matrices. And again, we multiply corresponding elements and then add them up. But when it really comes down to it, we've got a row times a column in each case. So this gets us in this case, a 1-by-4 times a 4-by-1 times 4-by-1. And in order for matrix multiplication to be defined then, as we've talked about it, these two inner numbers must match. So those have to be the same. And as a consequence, one nice thing is that the two outer numbers tells you the resulting size. So practice that here, and we'll move on then to the next size matrix and see how that goes.